I'm Libby Weaver. Thank you for selecting Keystone Learning Systems for your software training needs. In this introductory course, we felt it appropriate to take a minute and provide you with a few helpful hints. These suggestions will aid you in getting the most from the training. While effective learning can take place by simply watching the video and then practicing what you learn later on your computer, we suggest you use your TV and PC together. This allows for a hands-on approach where you can practice as you learn. In this see it, hear it, do it environment, you follow the actions taken on the video and pause the tape as you need to practice. You also have the option to rewind and review. On the back of each video cover, you will find our reference system. Each topic and number corresponds directly with the number on the actual video in the lower right-hand corner. If you need to find a subject, fast forward to that area on the tape. You can also use the search features on your VCR to locate specific sections. Keystone Learning Systems also offers keynotes with many of our courses. Keynotes are quick reference booklets that complement our video training. They provide information in a concise, easy-to-follow printed format. Please refer to the back of your Keystone catalog for a sample or call us for more information.
Hi, I'm Hani Gress with Keystone Learning Systems. In this tape, Pl-Sql Level 1, we're going to cover off all the basics. We're going to start off with a brief introduction to some of the new features of Oracle 8 as it pertains to Pl-Sql. Then we're going to look at the basic structures of the Pl-Sql program, some of the data types, some of the program control constructs, as well as exception handling. So what we're going to cover right now is basically some of the general new features of Oracle 8, in particular as regards to Pl-Sql. In terms of new features as regards to Pl-Sql, there are some significant new enhancements in Oracle 8. First and foremost is support for an object-oriented programming model. This is a big new area and a big jump for people used to procedural programming. Object-oriented programming offers us a great new way of looking at things through an abstraction of real-world entities, and it takes a little bit of getting used to. We'll be starting off with the pieces we need and then moving on to those features later. Another big feature is the support that Oracle 8 now provides for us to call external procedures. What this means, in fact, is that you'll be able to use the languages that you're familiar with, like C, C++, Java, and so on and so forth. Write yourself some libraries and have Pl-Sql basically make external calls to your functions. This will add a great deal of flexibility whereby you can use the operating system features and do the low-level stuff that you need to do off of the Oracle database and basically merge the two of them together and come up with a very powerful combination. One important thing to remember, however, is that the support initially will be only for C with the other languages to follow. Now, another new addition is support for new composite types. Some people call them container classes or arrays and so on and so forth. The two composite types that we have in Oracle 8 are called nested tables and V-arrays. And we'll be spending some time on understanding how those work. Another big area of support is in the area of large object support, in particular what we call B-lobs and C-lobs. These will allow us to have data, raw binary data, of up to 4 gigabytes in size. In addition, you'll see that Oracle 8 provides us a very advanced queuing model built right into the database engine. In the area of object-oriented features, we'll be able to create what we call abstraction. Abstraction is a powerful concept found in object-oriented analysis and design. It allows us to think of things in real-world entities that we call objects. When we look at things, we can then talk in things that we can relate to. Rather than talk about a car as made up of constituent parts, say an engine, a chassis, and so on and so forth, you'll be able to create a data structure called a car, and that car will be made up of other parts. Furthermore, this thing can be nested. The engine itself may be viewed as an object made up of many parts, and so on and so forth. So your models will reflect something much more close to the real world. Another major advantage is the use of protected data. So what protected data means is that the object will have a state. Basically, the state meaning the current value of the data that represents that object as it's being basically used within the application. Now, the state itself is controlled by methods, which means that we can't get access to the date unless we go through the interface the object provides us. This is a very powerful feature that allows you to protect your data, and when something goes wrong with the data, you will know by the very nature of how it was used, by which methods, what went wrong, and you'll be able to isolate your problems more rapidly. Not only do you get protection of the data, but you also are providing a series of very clear rules as to how you access the object by way of its methods. The combination of all the methods are what we call the object's interface. Now, this is a first cut of Oracle 8 as it moves toward the full-blown object-oriented environment. Therefore, not all the features we expect to see are there. There is no inheritance in the sense of the object-oriented model, and still very limited polymorphic behavior. I will be explaining those limitations later on when we talk about the object model. What Oracle 8 does provide us, however, is the ability to have persistent object storage. A moment ago, I talked about an object having a state. That state basically can be preserved by making the object persistent and have Oracle 8 store it in the database and bring it back when we need it later. This is a feature that even in many of the modern programming languages that support object-oriented systems do not provide. You don't have persistent objects in Java or in C++. You do, however, have this capability with using Oracle. Another powerful feature provided by Oracle is what we call the Oracle Object Translator, a facility that will allow other object-oriented languages to interface with Oracle 8 so that we can pass information to and from one object to the other, Oracle 8 being possibly the repository of our objects from a language such as C++ or Java. Another very important feature that Oracle 8 provides is support for very large database structures. Let's take a look at each of these points in turn. With regards to support for very large databases, Oracle 8 allows us to now partition tables and indices. Partitioning means taking a table and splitting it up into different parts, and a number of different indice models to work with those partition tables. We also have support for what we call star query hints for query optimization. In addition, very powerful extensions will be provided to allow us to have concurrent processes simultaneously gain access to the database. And all of the locking and so on and so forth will be handled directly by Oracle. So the ability to do operations in parallel is another major feature. And finally, support for what we call bitmapped indices are now provided. Another advanced feature provided by Oracle 8 is the support for advanced queuing. The features include a message-oriented middleware built right into the database engine. A store and forward model is guaranteed now by Oracle 8. In addition, we have a built-in data integrity feature that assures that messages are transactionally secure, meaning that you don't have to worry about the order things are sent. No two rows will be accessed simultaneously if you don't want to. Locking and all that mechanism will be handled for you. In addition, the advanced queuing features will be available directly from Pl-Sql. At the beginning, when I was summarizing all these features, I talked about the ability to call external procedures. This is a very powerful enhancement that's going to allow us to use all of the libraries outside of the database. Basically, hundreds and hundreds of library calls from C, C++, and so forth. Let's look at the major features in this area. External procedure calls are basically the use of what we call dynamic link libraries. Basically, these are libraries that reside on your operating system. They are called DLLs on Windows platforms, and they're called SO files, or shared objects, on the Unix platform, .so files. What this basically means is that you will have the ability to make use of these particular functions within these libraries and call them directly from Pl-Sql. In this first release of Oracle 8 supporting this feature, we will have initial support only for the C language, with more to follow. Languages such as C++, Java, and eventually for Corba will be provided by Oracle. In the area of new data types, this is a very exciting area. One major feature is support for what we call large objects, or LOBs, in the form of either binary or character data. The second point, though, is even more interesting. You will now have the ability to define your own data types, and this is basically the creation of your own object types. Furthermore, we're going to have support for CARs and varchar types that support the national language system. So you'll be able to have internationalization type features within your Oracle database. Now that Oracle allows us to take a table and partition it into many different tables, Let's take a look at some of the features and how they affect the row ID that we're familiar with. Oracle 8 has extended the features of row ID to permit taking advantage of the new Oracle 8 features such as partitioning. The row ID structure that we were familiar with earlier versions is, however, still compatible. So what we've just covered is basically a snapshot of all the new features of Oracle 8. We can't dive into showing all of these new features right away. The reason being that there's a lot of ground to cover before we get to many of them. Now, what we're going to start off with is basically the beginnings of Pl-Sql. We're going to start from the beginning and work our way up to when we can see use of these features we talked about. What is Pl-Sql? Basically, it stands for the Procedural Language / SQL. It is basically the combination of the data manipulating power that we get with SQL along with data processing language support that we expect from other processing type languages. We can do all of the following. We can basically use the SQL data manipulation commands, cursor control, and transaction control commands. We can use all of the existing SQL functions and operators, as well as all of the SQL data types are available to us. In other words, we can do selects, we can do function calls, we can make use of number, varchars, so on and so forth. Let's now go through a list of all of the features that are very specific to Pl-Sql and look at each of them in turn. So, what does Pl-Sql allow you to do? Well, you can use SQL statements to manipulate your data. You can use what we call flow of control statements to process it, and this would include looping, conditional testing, so on and so forth. You can declare constants, you can declare variables. You can also create modular units like procedures and functions. You can catch exceptions, or what we call runtime errors. And furthermore, you can group all of these together in what we call packages, which allow you to start modeling more closely what we call an object-oriented model and take advantage basically of object-oriented analysis and design features. Another very important feature of using Pl-Sql facilities are that you'll be able to provide grants on your procedures and your functions, and the use of these things will be used by users who otherwise would not have access to the table. Let's look at the features with regards to those areas. We'll be able to grant privileges to a procedure. What this means basically is, let's suppose you had a procedure that did updates on a table. The table itself is not granted access to the users directly. That means that the users can't look at the table, but they do have privileges granted to them that allow them to use the procedures you provided so they can gain access to the table. The other thing that's also available is implemented object relational functionality within Oracle 8. And we'll see these features a little bit later. Now, one good way to understand why Pl-Sql came about is to look at how it evolved. What were the kinds of issues people were struggling with prior to Pl-Sql? Let's look at a typical scenario. Now, here's an example where you are doing what we would consider a very typical banking transaction. We are going to debit account A and we're going to credit account B. Now, in order to do this successfully, we have to remember that we need to do two updates. The first update, we're going to set the balance to be the amount minus whatever that debit amount is for the specified account number. In the second case, we have to make sure that this always goes in sync with the first. We're going to update the second account. This time we're going to credit it by some amount for that particular account. Now, what was wrong with the last sequence? Basically, we have to do two updates, one in succession. The problem with doing it is if you forget one, basically you've done only half the updates. It is prone to error. However, when you use a Pl-Sql procedure to do this, you implement the updates within the procedure. The user needs to only call the procedure, define the amounts that they would like to debit or credit, and the procedure handles all the details. There's no forgetting one if you do the other. Now, just for informational sake and a little bit of the history of Pl-Sql, it came about with its first release about the same time as Oracle 6. That was version 1. In version 1.1, it was only available within the Oracle Developer 2000 tools. Version 2 came about with Oracle 7 Server, release 7, and version 2.1 came a little bit later, release 7.1. The versions of Pl-Sql most widely used today are 2.2 and 2.3, both with Oracle 7 Server, releases 7.2 and 7.3. And the latest version, the one we'll be talking about now, is version 8.0, which is available with Oracle 8 Server. Now, Pl-Sql is made up of many different parts. Let's look at how it fits into a database application model. Now, there's a number of different ways to use this. Let's imagine for a moment that you have a third-party product. Basically, it can invoke any of the stored programs that you write on the server side. They invoke, in turn, the Pl-Sql runtime engine, and they get processed and results are returned. Another case is where you might have a local Pl-Sql program basically invoking the local Pl-Sql engine. So you have support for a client-server model or a standalone application. On the server side, there's a lot of power in putting stored programs stored on the server. They can keep the information accessible through a very consistent ways to those people that are using that server for a variety of tasks. It's a very powerful construct, and we'll see how we can use all of those features as we move along the course. Now, when we start programming with Pl-Sql, there's a number of important things to learn. If you're new to programming, there's a lot of different concepts you have to learn, and you should form some good habits now. Let's learn about some of these habits. It's important that you develop a coding style which will improve your readability and maintainability of the code you write. Indenting your code is extremely important, especially if you're using conditional type structures whereby the different blocks corresponding to the different conditions, true or false, become much more readable if you use indentation wisely. You should also use a combination of uppercase and lowercase where possible to accentuate the keywords in the statements. The statement, for example, select column 1, column 2 from table A, is more readable when you sort of use a combination of uppercase and lowercase as we've done there. Also, things like if condition, then becomes also a bit clearer, as well as the begin statements end. Now, we're not enforced to have to do any of the things I just mentioned. They're guidelines. However, if you start forming good habits now, your code will be more readable, much more maintainable, and you'll find that in the long run you're going to benefit by not having to support as many bugs and fixes and so on and so forth. So it's important that you establish these habits now. Now, to drive this point home, look at the following set of statements that are not using indentation. Here we've got the before condition. If this num greater than 10 and so on and so forth, then new val equals 10 and so forth. Now, I know we haven't talked about many of these statements now yet, but just look at the code itself and compare this code with the following code. Indentation allows us to quickly see the conditions we're trying to get at. We can read much more cleanly what are we trying to say here, rather than have to read the entire block of code in order to get an understanding. So indentation shows you the flow of the program much more clearly. And in particular, when you use indentation levels for deeply nested conditional blocks, you'll find that it is a great advantage to use well-nested, well-indented programs. Another extremely important area is that you also remember to comment your programs. Comments are a feature that you should use. The problem with comments is that people always feel that after they've written their code, they're going to go back and comment it. The problem is that doesn't happen in practice. Once again, resist the urge to ignore putting comments in, because you'll find you'll understand your code much more a couple of months later. For example, if you put comments in, you might jog your memory as to what you were trying to do or say. But without comments, you'll find that your code will seem as foreign as someone else's code. And this is, again, one of those habits that if you form early, you get in the habit of doing it, you'll find you're doing it without thinking anymore. There are two types of comments. One is what we call the C style, and it's supported by C, C++, and Java. And a comment is everything in between the opening of a slash followed by a star, up to and including a star followed by a slash. This allows you to create what we call a block comment. Inline comments are basically supported as well. And these are indicated by putting two hyphens or two minus signs side by side to indicate that the remainder of the line is what we call an inline comment. Everything from the beginning of the two minus signs to the end of line will be ignored. So what comments are, in fact, are text that we put in the code only for our own purposes, only so we can put some kind of commentary as to what this piece of code is doing. Again, I strongly urge you to use comments and use them wherever you want. It's something that it will be clearer for you. It will allow your code to be more readable by yourselves and your peers. Here is an example of a comment block. As you can see, the particular style used would differ and depends on your organizational stipulations at what are the comment should look like, and so on and so forth. If you're at liberty to do any style you want, it's entirely up to you. But here, for example, we see that we have the author's name at the top, what parameters are coming into this particular function or procedure, a short description of what this particular function or procedure does, followed by all the objects that are affected by this particular procedure. Now, at this point, we're probably dying to see a little piece of Pl-Sql working. But before we get there, we just need a few other syntactic issues out of the way. Let's take a look at how we terminate statements. What we call a Pl-Sql block is basically a series of statements. Each statement is terminated by a semicolon. This, again, is not going to be unusual to C, C++, and Java programming. For those of us that are new to programming, however, you'll find yourself missing the semicolon quite often. So just remember that one of the basic rules is you have to put a semicolon to terminate each of your statements. Here's an example of the semicolon delimiter. We have if some salary is less than a minimum salary, and that condition is met, then do the following expression, end if, semicolon. Here's another example of a couple of statements. Declare, founded as a Boolean, initialize it to true. Salary factor is a number. It's initialized to 0.25, followed by a semicolon. So don't forget to put the semicolons at the end of your statements. So as you can see here, the arrows are indicating the positions of the semicolons. And as I was saying earlier, it's one of those things which is very easy to forget, and you'll see a syntax error and you'll quickly forget them, quickly fix them, and eventually it'll be very habit-forming. Now, a language like Pl-Sql, just like other languages, have what we call meta characters. What are the characters that make up the components of the language? Let's take a look at what meta characters exist in Pl-Sql. The Pl-Sql meta character sets include normal letters, upper and lowercase, everything between A and Z, digits, the following symbols, and you'll see them, they all have different meanings. Equal sign, the exclamation is used for inequality, the at, the pound sign, and so on and so forth. We will see each of these in turn as we move along. What we call white space basically are characters that you don't see when they're typed in. And these include the tabs, spaces, and carriage returns. A statement delimiter we've seen a moment ago, a semicolon. %, we indicate that as an attribute indicator. And you'll see in a moment that that means something that we can anchor an attribute to a variable. We'll be seeing that a little bit later. Now remember, in SQL, the % indicates a wildcard, 0 or more characters when we're doing something like a like statement. And finally, the underscore, which means a single byte wildcard within SQL. Now, it might seem that there's a tremendous amount of different meta characters in there, but as you'll see, as you learn each of them in turn, it's no different than any other language. There are, however, a few more we need to cover off. Let's look at the additional ones. The colon is used to indicate it's a host variable, and we'll see that, for example, when we do a trigger and we want the old value and the new value, that'll come into play then. The double star, which indicates exponentiation. The inequality, left and right chevron, or the bang equal. Concatenation of strings, which is familiar for most of us from SQL. A label delimiter. And relational operators, less than or equal to, or greater than or equal to. And finally, and a very important one, is assignment. Assignment in Pl-Sql is done with a colon equal, very similar to the Pascal language for those of you that have done Pascal. In addition, we have what we call the association operator, and that's used for positional notation. We have the two comment styles we talked about, the double hyphen and the /**/. And finally, the null statement, which indicates do nothing. Now, we're almost there. All we now need to know is what is the structure of Pl-Sql program. Once we've got that covered, then we can go off and see a simple Pl-Sql program in action. A Pl-Sql program is what we call a block-structured language with little units. These units are what we call procedures, functions, and basically blocks that are not given a name, and we call them anonymous blocks. These are basically what we call the logical blocks of the language, and they can contain any number of nested subblocks. Each block is basically made up of 4 parts. We have what we call the header, followed by the declaration section, followed by the part that does the work, which is called the execution section, And finally, the last block, which is the exception section, this is where we trap any errors and do any special handling that we might require. What we're going to do next is look at all of the different steps involved in building a Pl-Sql block. The very first thing you're going to do is define the type of block. Is this going to be a procedure, a function, an anonymous block, or is it a method in Oracle 8? And again, that's part of the object-oriented stuff that we're going to see a little later. The second step is to declare any variables that are required within that block. So do you need any variables within this particular block you're executing? Finally, we can use the local variables as well as other Pl-Sql objects to perform the actual processing of the data. And finally, handle any errors that may arise during execution by providing code within the execution block section. Now, the next thing we're going to look at are some little simple rules, and then we'll actually move on to SQL Plus and do a small example. A very important rule is rules regarding scope and visibility of variables. This is one that's hard for new people to programming in general, but basically a variable is the name you're going to give to identify some area in memory where you're going to store some information of some type. For example, you might want to have an integer counter, or you might want to have a variable that holds a string, or anything like that. You're basically naming this variable by what we call an identifier. Now, where you declare it is extremely important. When you declare a variable in one Pl-Sql block, it's considered local to that block and then global to all of the subblocks contained within it. When execution of that block terminates, the declared structures, the variables of that block, no longer exist. If a global identifier is redeclared within a subblock, only the local identifier is visible within that subblock. What that means is, it could be a source of error if you're not careful in what that means. If I declared a variable called x in an outer block, and I'd renamed the variable x in an inner block, I will see the inner block x, and I'm in essence hiding the outer block x. If that's what I wanted, that's fine. I would basically be using the local x unaffecting the outer x. But generally, that's not something we do by design. It's usually a cause of errors. That's why naming your variables very carefully is extremely important. Another important rule to bear in mind with regards to scope and visibility is that a block cannot reference identifiers, in other words, other variables, declared in blocks nested at the same level. They're basically hidden from you. You can't get at them. Let's take a look at this very simple anonymous block. Now, it's anonymous because it doesn't have a heading. It's not named anything. It's not a procedure. It's not a function. It has a declare section, and as you can see, we declare a variable called x. It's of the type number, and it's initialized to 0. Then we have another variable called counter. It's a number, and it's also initialized to 0. And then we begin the block. The begin section indicates that we're commencing that block. We're saying, for I, being in the range of 1 to 4, continue looping. Every time we enter that loop, x is going to be incremented by 1,000, and the counter will be incremented by 1. Then we're going to do an SQL insert statement into some table called temp. We're going to put the values in of x, counter, and then the outer loop value. Now, within this inner block, we're going to go off and declare another variable called x. And this is the local version of our x. And then we're going to begin an inner block. We're going to do the exact same thing, and we're going to store this x inside the table. But as you'll see, this particular x will be the local x of this inner block, and it will have different values than the outer x. Finally, we're going to do this loop until we do it 4 times. We leave the loop. We end the inner subblock. We continue looping through the outer subblock. We commit, and we end. Now, this might seem a lot to take in at once, but we're going to see this done interactively, and we'll see all the different steps involved. Now, what we just saw was rather complex, but if we break it down piece by piece and do it interactively using SQL Plus, you'll be able to see all the pieces fit together, and you'll understand the rules of scope and visibility better. Now, in order to understand this example more completely, we need to set up the pieces that make up the example and then build up to it so that you see it all from beginning to end. The very first thing I'm going to do is create a table. And this table that we've created here, or that we're going to create, is similar to the one that we're using in that example to populate information. Now what we're putting in the table, if you look at the notes, is basically a number, and we'll call this simply column 1, and that's a number. And in column 2, we're putting basically nothing more than another value, so it's another number. And in column 3, we're putting in some text, so we'll call that column 3, and we'll call it a var car 2, and we'll say it's no bigger than 20. So that's a definition of a very basic table. And just to make sure we understand the operations, if we insert into temp the following values, we'll put in 1, 1, and the string test. And now if we basically look at the contents of this table, we see that everything is as we expected, and then we can roll it back and do the select again. And so there's basically an empty table. And now this is one of the parts done within the inner and the outer looping blocks of that program we have in the notes. So what I did so far is nothing more than your run-of-the-mill SQL. If any of that parts I've done was a bit unclear, you need to just look at how we do the creation of a table using the data definition language create table. Then how do I actually insert information into a table? We use the insert statement. That's one of the data manipulation commands. And finally, when I wanted to basically get rid of it, I would roll it back, or I would do select statements to see the contents of the table. So all of that is your basic run-of-the-mill SQL. The power of Pl-Sql comes in the fact that we can combine this type of capability with the capability of some procedural logic. Let's see how we can do that. So let's do just an outer block first, and then we'll amend our program to create an inner block, and by doing so we'll understand the issues regarding scope and visibility. So this is an anonymous block, so I'm simply declaring the declare section, and the heading part is basically omitted. So it is nothing more than your run-of-the-mill anonymous block. We're going to declare a variable called x. We're going to say it's a number. We're going to talk about the data types in a moment, but for now this is very similar to the data types you're familiar with from SQL. So it's basically a number, and it has a value, initial value of 0, and then we're going to create another variable which we call the counter, which is also a number, and it also has an initial value of 0. Now that's it for the declaration section. What do we do in the begin section? Well, in the begin section, all we want to do is basically create a very simple loop, and we're going to say for some variable I and some counter. So we can here say for counter in 1 to 4. What do we want to do within this thing? We want to simply loop. So as we loop through, what do we want to do? We want to basically do some operations on x, and here's an example where we use assignment, and we'll add 1,000 to x every time we go through. Remember, x was initially 0, so at this point we're adding 1,000 to x, so it has a value of 1,000. At this point we want to insert into this table that we know exists called temp, and the values we want to insert are, we can basically put them all here. We want to put in the value of x, whatever the value of the counter is, and finally a little message that will say what part of the code are we in. We're in the outer loop. And you'll see a little later when I amend this, we'll indicate we're in the inner loop. So there you have it. That's the insert statement, an SQL statement, to insert into that table the following values. At this point we're going to stop the loop. We're going to say that this is the end of the loop body. And to do that we use the end loop command. And then we're going to end the outer block, and we're going to say end. So that's it, a very simple Pl-Sql program made up of all the sections we talked about. We're missing the header, so it's an anonymous block. The declare section declares a few variables. The begin to end section is declaring the executional portion. And finally, we have no exception section, so that completes the block. What do we have to do? We have to first compile that block and execute it. And we do that by simply saying, go ahead and execute those instructions. And at this point, it claims that everything was successfully completed. If that is the case, if I now do a select on the table I built, you can see that the table now has real data. And the script basically populated the table. And we know from before entering the script, the table was empty. So clearly our program did what it was supposed to do. Now what we're going to do next is basically create an inner block. And within that inner block, we're going to declare X as well. And we're going to see the effects of the local variable versus the variable declared in an outer scope. That'll give you a good handle on what we mean by visibility. Now, in order to save some typing, what I'm going to do is basically leave everything that we see here. And this is what we were doing within the outer loop. So I'm going to basically cut that out, make a copy of it, and I'm going to simply paste it in here. And so I'm in the outer loop now. Now what I want to do is basically go ahead and create an inner loop. Now how do I do that? Well, again, I keep my indentation clear, so I can see here that I've got a new declare section. What am I doing in this declare section? I'm going to declare another variable X, and I'm going to say that this X is a number, and it is going to be also initialized to 0. Now this X is very different from the outer X. This X will be the X that's going to be seen within the begin statement, the begin block of this subblock. So begin now, we're beginning what we call the inner block, and in this inner block I'm going to basically do nothing more than repeat the operations I talked about. So here I'm going to simply say for let's just say for I in 1 to 4, continue looping. And then at this point, I'm basically going to do the addition of X again. I'm going to say X colon equal X plus 1. So we want to make a distinction between the X in the outer one and the X in the inner one. And then at this point, I need to do the exact same thing I did earlier. I'm going to say insert into the table temp the following values. And the values are going to be the value of X, the value of the inner loop. Actually, we'll put the counter for the outer loop as well. And we'll put a different message. We'll say this is the inner loop. So once we've done that, that's the end of the insert operation. Now we can basically end this inner loop, and we can end the complete execution block of the inner subblock. And then the remaining parts of the script, we can actually go up here and take these two lines here, which are the way we terminated the previous one. So we can just simply paste them in. And as you can see, I pasted them in. I lost some of the indentation. I didn't hit a tidy one. So here we have it. I've listed it all. So we've got the outer block, and now we've got the inner block. We try and compile it, and then it says that it successfully completed. Let's now look at the contents of our table. And what do we have now? As you can see, we've got outer block and inner block data. And why do we have so much data? Well, we know that we originally had these first 4. That's the first execution of the outer block, followed by 4 local executions of the inner block. The second outer block, followed by 4 more inner blocks, and so on and so forth. In other words, you can see clearly that the X values of the outer and the inner block are totally different variables. The local one has local visibility, and the outer one has global visibility, but it's hidden by the local. Now at this point, there's a lot of the Pl-Sql that we have not talked about. We have not talked about looping and all that other stuff, but we'll be seeing that in the upcoming sections. Now what's important now is, what are the Pl-Sql data types that you're allowed to declare? Now here are some of the Pl-Sql data types that you're allowed to declare. You're allowed to declare what we call binary integers, and these are basically signed integers. You're also allowed to have what we call a Boolean type, which allows you to store the values true or false. You also can have a decimal data type, which allows you to store decimal numbers. Finally, you can create small integers that we call the small int, as well as numbers very similar to the SQL number type. In addition to that, you can have fixed length character data, same as SQL, called the car, and so on and so forth. So where can we use variables and constants? Let's take a look at all the rules regarding the areas where you can use them and declare them and so forth. Now, variables and constants can be used anywhere in SQL and procedural statements. Anywhere an expression can be used. In other words, where you would have been allowed to use an expression, you can use one of those variables or those constants. They have to be declared before you use them, however. They have to be declared within the declarative part of the Pl-Sql block. In other words, the section where you go declare. Basically, space is made available for that value. You specify its data type, and the name you give it is specifying its storage location so you can get at it. So earlier when I was saying x is a number, x is basically the name of that storage cell where we're going to be storing values for x. As we want to refer to x, we simply refer to the storage area by the name of the variable x. We know its data type. Pl-Sql gives you the current value of the variable x. Now, variables can have any valid SQL data type or any valid Pl-Sql data type. The default values can be specified for variables using the following syntax. The variable name followed by its data type, followed by the assignment operator and a value. In other words, an example would be x number : equals 0. We're declaring a variable called x of the data type number, and its initial value is 0. Or you can declare it using the syntax x followed by the data type number followed by the keyword default followed by the value 0. Which style you prefer to use is entirely up to you. Now, one of the most important types of operations you're going to do is assign a value to a variable. Let's look at the rules regarding assignment. Now, one of the most important operators is the assignment operator. That's a colon followed by an equal. This is used whenever you wish to assign a value to a variable. A simple example is x : equals 5. You're assigning the value of 5 to the variable called x. Another example is where you are going to do an assignment is where you select a particular column and you use the keyword into, and you're saying select salary times 0.1, store it into a variable called bonus from the table employee. In other words, you're assigning it to a variable, and bonus can then be used within the Pl-Sql program. Let's now look at a little program segment and see how we've assigned different variables, different values, how they've been declared using the various notations we've just seen. Now, the declare block would have something like a variable declared as founded of the type Boolean, hire date of the type date, total costs of the type number with a precision and scale of 15 and 2, a variable called text description, which is a varchar 2 of length 2000, a variable called loan term, a number. It has a default value of 6. Or another way of saying is that we're going to assign a variable a value, loan rate being assigned the value 0.625. So these are all just simple examples here of how you would do all that. Let's now create a very simple program in Pl-Sql, and we're going to create and declare some variables, assign them some initial values, and see how we would use them within our program. So what we're going to do next is basically declare a small program, and within that small Pl-Sql program I'm going to declare a few variables of different types, just so we can see the different syntax that is available. We can say declare, and here we're going to declare a variable called x1, and it's a number, and we're going to give it an initial value of, say, 10. Then we're going to declare a variable called x2, and it's a number, and we're going to give it a default value of, say, 20. We're going to declare a variable called x3, and we're going to give it a varchar type, varchar2, say, of 1000. And here we'll not give it an initial value. And that'll be enough just to make the point of how we would use it. Then the begin block, we're basically going to say x1, actually we'll give x3 a value. This is called assignment as opposed to initialization. We are assigning x3 a string, and we'll call it test data. And so this differs from the first two in that x1 is initialized to 10. Initialization can only occur once, whereas assignment can occur any number of times within the block. So let's just look at the results we have. We'll just simply output them using dbms output dot put line, and I'll just simply put out the variables here. I'll say x1, concatenate it with a space here, concatenate with x2, concatenate it with a space, and finally x3. So we're just going to display this stuff on our output. And finally we'll end the block. So as you can see, the results are the first variable had a value of 10, so we know it was correctly initialized. The second variable had a value of 20, it was correctly initialized. The varchar was correctly assigned test data. And as you can see, it came out. Now, one extremely important point is dbms output. I haven't talked about it, but we'll be using it a lot, and later on I'll be explaining what it is in detail. Now, what dbms output is a package. And now, I briefly alluded to what a package was earlier. A package is made up of functions and procedures. They are basically collected together or packaged in this unit that we call a package. Now, dbms output happens to be a package already available for us, and we just go off and use it. Now, as you can see here, I used one of the functions in that package called putLine. I basically gave it some data, and it displayed it on our output. But there's some important things to be aware of when we use that package. Let's look at those issues. When you're using the package, one of the most common errors is to forget to turn on the facility that says I want to see it run. So if I say set server output and I say off, if I were to rerun this particular script here, if I go ahead and run it, notice I got no output. And that's because I turned off output. Guess what? The default is it's off. So if you type this in as we're following along and you got no output, don't panic. All you got to do is basically type that you want server output on, then rerun it, and you're going to see your output. So that's an important thing to remember when you use that package. We're going to talk about the details regarding that package a little bit later. Now, in order to save a lot of time, Oracle gives us a very powerful feature called anchoring. Let's suppose I'm working with information from a table. Now, that table has certain columns, and those columns have certain definitions. This column 1 is a number, column 2 is a car, and so on and so forth. If I had to declare my variables by knowing what the column types were, and then somebody changes the column definition in the table, I have to go change my Pl-Sql program. But with a feature called anchoring, you don't have to worry about that. Let's take a look at how we use it. Basically, an anchored declaration or attribute is nothing more than a property that lets you reference the data type and the structure of an object without having to repeat a definition that was anchored to a previous data structure. In other words, I can declare a variable, and I could say this variable is called whatever, but this variable is of the type of whatever type it is within that particular object. In other words, I can say, if the data type of this column is a number, I want this variable to be of that data type. Furthermore, if you go ahead and change the structure of a table using an alter table command, and you change the data type of that column, my variable will still accurately reflect the new data type. So again, it saves you a tremendous amount of time. All Pl-Sql variables and cursors have attributes, and so you can use them in that fashion. An anchored type definition will basically give you a great deal of advantages over you declaring explicitly the data types. Let's look at each of the points of these advantages. The important points are that it is totally synchronized with the database column definitions. We don't have to worry about that at all. It also allows for normalization of local variables, and it's resistant to business changing requirements. In other words, if a particular definition changed later, your variable already sees that definition change, and you don't have to change your Pl-Sql program if you wrote it using an anchor type declaration. The syntax of a type definition is the name of the variable, followed by the type attribute, followed by the keyword %type, and then any optional default value. The %type attribute provides the data type of a variable or of a database column. Let's look at some examples of using the %type. If I declare a variable called myTitle, its type is based on the object called books with its sub-object called title. Now, title is probably the column of a table called books. %type says, make my title be anchored to the type of whatever that column type is. So if the title was a varchar, if this title here was a varchar, then my title becomes a varchar. We can look at another example very similar. We have a variable declared called local sales. It's based on the column called sales figure of the table revenue. By saying it's %type, whatever type sales figures are, local sales will be also of that type. You can also nest it. Now recall that local sales is of a type of whatever sales figures are. You could say that the total sales and the annual sales and the quarterly sales, the variables over here, will also be anchored to an already anchored type. So these things nest. So if you change the data type of sales figures, all the changes get reflected across the board. Local sales, total sales, annual sales, and quarter sales. They all take on the new type. So we can better understand anchored types. Let's take a look at a small Pl-Sql example where we're going to make use of an anchored type. Then we're going to alter the table, and we're going to see that the program still works. Now let's take a look at our table that we have earlier here, describe the table temp. As you can see, it has a number of columns, column 1, column 2, and column 3. Now if we write a small Pl-Sql program that was basically going to use those particular columns or declare variables of those columns, we won't have to change their types if they're going to be used as an anchored type as opposed to having to declare them explicitly. Let's take a look at the consequences of that. If I say declare, and I'm creating a new block here, and I say I want to declare a variable called x1, and it is of the type temp.c1 of whatever type that is. At this point, x1 will be a number. But x1 will be whatever c1 is. So if later on c1 became something else, x1 will be that something else. And then I can simply do a begin here. And within this begin, I can basically select information and store it into x1. So let's see how this works. I'll say select, and I'll select column 1, and I'll put it into the variable called x1. And now I don't have to worry about the types not being the same because x1 is anchored to whatever column 1 is from the table temp. So if I select it and put it in there, and then I could simply output it and say dbms output dot put line, and I'll simply say this is the value of the variable. I'll say x has a value, and I'll just display it. So very simple output statement here. So we'll just simply end this anonymous block, and I'm going to go ahead and finish it off here and just compile it. And I've got a typo here. I created the variable text1, and I called it x1. I called it x here instead of x1. So let's just quickly fix it. So I'll just list my program here, and I'll go to line 5, and I'll just do a change. And as you recall, we covered all this in the intro part. Change x parentheses with x1 parentheses. And so you see the corrections there. We can list the program now, and now we can go ahead and compile it. And we've got a small error in the select statement. Now, what was the problem here? And this is one of the more common problems when you're dealing with SQL and Pl-Sql together. x1 is simply a variable, one variable that has a cell or a position in memory to hold one type. But what am I trying to do in there? I'm trying to bring in everything from that entire column and store it into x1. And that's exactly what this message is saying, that exact fetch returns more than requested number of rows. Let's take a look at what's inside temp. So if we look at what's in temp, we see we've got a number of different variables. So how do we basically bring back only one result? Well, we can use a number of different choices. One is we can say sum them all up or give us the average of column 1 or anything. But the important thing is that it gives us back a single result. So what I'll do is I'll just list the program again. And actually I've lost it because I've overwritten my buffer here. So I'll just go back and get it quickly. And so here's the program we have. Make a copy and paste it back in. And so if we now list it, we'll see what the problem is. The problem is on line 4. And it's important to see that you get this kind of information from the output. It's telling you line 4, and so you know immediately what's going on. Now at this point I'm going to go to line 4, but instead of saying selecting C1, I'm going to say rather, so instead of C1, give me the, say, the sum of. We'll just do the sum of C1. And this will give us back a single scalar value. So if I list it back now, go ahead and compile it, you see that X has a value of 20,040. The number itself is irrelevant. Now, let's look at what happens if I basically were to change the type of that column. If I were to change the definition of temp here to something other than a number, this program would still work. And why would it still work? Because X1 is whatever the type C1 is. Therefore, it makes this program totally resilient to any changes you do. And that's why you should always prefer to use an anchored type versus you doing a definition yourself. In other words, if line 2 were X1 number, that may work in some circumstances, but it will not work in all circumstances. But by saying that X is anchored to C1, you don't have to worry about the changes that may occur. Now, an important construct in any programming language is the ability to have controlled flow. And Pl-Sql is no different than any other language in this regard. Let's take a look at the control structures available to us. Now, what are control structures? They are the structures within the language that allow you to process data using conditional, iterative, and sequential flow of control statements. Let's take a look at some of the details in this area. The most important one in terms of conditional control flow is the if-then-else structure. What this allows us to do is to execute a sequence of statements based on some kind of condition. The if clause will check the condition. If this condition turns out to be true, the then clause decides what is it we want to do if the condition is met. In other words, if the condition is true, this is what we should be doing. If the condition is not true, the else clause defines what it is that we should do if this condition was either false or null. Here's an example of an if-then-else statement. Remember, you can also nest them. And that's where the indentation becomes extremely important. If the condition is met up here, then you're going to end up executing this entire block in here. If this condition is met, then you'll execute these statements. Otherwise, if this condition is met, you'll execute these statements. Else, if this condition is met, you'll execute these statements. In other words, the logic is determined whether or not something is true or false. We won't even enter any of this. If condition is initially false, you'll end up branching right out of here. And so, if-then-else structures are used whenever we want to control the flow within our program. Now, what we're going to do next is basically use an if-then-else structure to show how we can alternate the display through our table temp based on the values of whether something meets a condition or does not meet it. So let's look at what's in our data. You see we've got a number of bits of information in there. What if we wanted to display all of the small values one way and all of the large values another way? So say our inner loop values or our outer loop values. How would we do that? Well, we can basically create a small SQL type Pl-Sql block. And we could say declare. And here we might want to declare a variable. We don't have to. So we'll simply go begin. In this case, we don't want to even bother declaring anything. And I want to basically create a kind of a condition where as I flow through something, I want to determine whether this is true or this is false to take on some action. So how would we do that? So what we're going to do is basically update this information in this table based on, say, the value of a loop variable. just so we can see the results of a condition being met or not being met. So we'll simply say for I in, say, some range here, and we'll keep it small, say 10, loop through. Now every time you're looping through, what is it you want to do? Well, this is where doing a test comes into play. We're going to say if, and here the condition will be, we're going to call a function called mod, and we saw this as one of the standard SQL functions. If the mod function returns a remainder of 0, in other words, if the number is completely divisible by 2, then and only then we know the number is even or the number is odd. So what we can do here is we can do whatever, and we'll just make it interesting. We'll update that table. So we'll insert into temp, and we're going to put in the following values. We're going to say the values are going to be, say, I and even. So again, we're just really using this table as a scratch pad for our testing. Now, if the condition were not true, then you would have to execute the opposite of that condition, and that's called the else clause. And in this case, we're going to go off and do an insert again. And in this case, the insert into temp will put a slightly different message out. The values in this case will be I, followed by the message odd. So you see we have two different conditions, and then we finish off the block by saying this is the end of the if statement. And then we can finish off the loop by saying this is the end of the loop statement. And finally, this is the end of the entire block. So let's see the block completely now. As you can see, the indentation makes your program very readable. The loop goes through 10 times. Each time through, the value of I is being tested by this condition. If the remainder of a division by 2 is 0, the number is even, and we do an insert operation. If the division of I by 2 is non-zero, we know it's an odd number, and so we insert this entry here, which inserts a little message indicating it's odd. When we go off and execute this, and now we take a look at our table content, select star from temp, you'll see that the whole latter half of this table, the 10 values we've just put into it, indicate that when I is 1 it's odd, or 2 it's even, and so on and so forth. So as you can see, using if then else logic allowed us to take a different insert operation to be done based on the value of a variable. And this is exactly what conditional control flow is all about. Now, when you combine conditional control flow with iterative control flow, basically looping operations, you end up having a lot of power at your disposal. Let's look at what choices we have in terms of iterative control flow. We have a number of different ways of doing the same thing within Pl-Sql, which is similar to the choices we have in many other languages. The loop statement indicates that you want to execute a sequence of statements a multiple number of times. The keyword loop goes before the first statement within that sequence. Finally, the keywords end loop go after the last statement within that sequence. The for loop statements let you specify a range of integers, and then executes those statements once for every value within that range. We've seen it in action already when we said for I in 1.4 loop. In other words, we're saying I would take on the values 1 through 4 inclusive. Finally, another loop is the while loop. The while loop statement will execute a sequence of statements so long as the specified condition is true. If the condition becomes false or null, control then passes on to the next statement after that loop. Finally, the exit when statement lets you exit a loop if further processing is not desired. So we have so many different choices here. The hardest decision to make is when to use one loop versus another. So if you're new to programming, you're probably wondering, well, when should I use a for loop? When should I use a basic loop? When should I use a while loop? Since they all seem to do the same thing. They let me loop over a number of statements a certain number of times. Well, it turns out that in practice, there's a couple of rules of thumb that'll make it easy for you to decide which one to use. You would use a for loop if you are going to sequentially loop through a sequence of numbers, say like 1 through 10 or whatever. You would use a while loop whenever you have something very general. The condition, you don't know maybe at the start exactly how many times you're going to loop through. You're going to loop through so long as, while as the condition is met. That's precisely what the while loop is for. Let's now look at some examples, first on the foils, and then we're going to move off to the SQL Plus and do a few programs interactively making use of these different looping features. Now, the for loop example, let's take a look at a case we've seen already, and we just did this a moment ago interactively. But let's focus only on the for loop portion. A variable x is declared, and that's in the declare section, and this is very typical, and we're used to that already. Now, within the begin-end block, we're saying declare. We want to declare that we want to have a loop. Remember that the loop indicates it's everything between the loop and the end loop. So the loop precedes the first statement, and the end loop follows the last statement within the block. You can have any number of statements within that block. Within this block, there might even be additional looping constructs within them as well. And when you have one loop inside another loop, we call that a nested loop. Now, we're saying I flows through between 1 and 10. We loop through, and so every time we go through the loop, I will take on each of the individual values within this range. The first time through the loop, I will have the value 1. The second time through the loop, I will have the value 2. Up to the last time through the loop, I will have the value 10, at which point it will have gone through the entire range, and we will come out and commit the changes. Every time through the loop, we execute whatever these statements do. In this case, we've seen this. We're saying, call the mod function, passing in I. So every time we go through the loop, I takes on a different value. So the very first time, I will be 1. This will fail, because I divided by 2 is not going to give 0 remainder. So we would execute this part of the if statement. The next time through, I would take on a value of 2. This test would pass, and we would execute this portion. So as you can see, we can loop through the statement block a certain number of times, and we can have the conditional control flow combined with the looping control flow allow us to do this powerful combination of features. So whenever you're doing something very structured, very sequential, the for loop is the ideal loop. When you're doing something very general, you're not really sure the number of iterations you need, the while loop is ideal. Let's look at the while loop. Now, the very basics of the while loop are very similar to the for loop. The while is made up of a loop, end loop clause, and everything between the loop and end loop get carried out that number of times. Now, the while loop, the basis of it is that while some condition is met, in this case, while more data. Well, what's more data? More data turns out to be a variable of the type Boolean, and it's initially true. So, the first time you enter into the statement, you're saying, while more data, it is true, so we loop through. Then we do some operations. We get data, so we call some function. We do some counting. We display some data. And then we say, if the count is 10, then more data is false. So the variable more data becomes false, at which point eventually, after going through this a number of times, we go back to the top every time and we test. When more data becomes false, the while loop test fails and we don't loop, we come out of the loop and we execute what follows on here. What follows on here in this example happens to be nothing, so that particular block would then complete. Finally, another type of loop you might have is a loop which you're going to loop over a certain number of times until some exit condition arises. Let's look at how that one works. So within this loop, we might be doing some kind of operations. We might basically go and get the balance from some kind of account. If this balance becomes less than 1,000, then we say exit. And this exit statement will take you out of the loop, and you would basically be out of the loop. If the exit condition is not met, you would do apply balance, and you would stay in the loop, and you would continue carrying on. Eventually, some condition would arise that makes this balance remaining become less than 1,000, at which point you exit the loop, you come out here, and you carry on with whatever remains in the Pl-Sql block. So that last loop basically shows you how you can prematurely get out of a loop with the exit clause. Now, the final loop we're going to look at is exit when. Let's take a look at how we use that one. Now, this particular loop is very similar to the last one, except we're basically putting the condition right on the exit statement. So here's our loop, loop and loop. We're going to execute all these statements. The balance remaining is computed the same way. And here we're basically getting rid of the if statement and combining all of this into one single exit when condition. Exit when this condition, balance remaining, becomes less than 1,000. So when this condition is met, what happens is the loop statement here, exit, is honored, and you exit out of the loop. If the condition is not met, you carry on in your code, you apply the balance, and finally you go back to the top, you keep doing the operations until the condition is met. And that's why it's called an exit when a condition gets honored. Let's now look at some very simple examples of all of these different loops in action so that we can see concretely how they get used. We won't work with tables, we'll just use DBMS output just to create different cases where we want to see the various conditions. So what I'm going to basically do is create a very simple begin block. I'm going to say for I in 1 to 5, and I'm going to say loop over the particular statements here. And I'm simply going to go DBMS output. I'll do a very simple put line. And here I'm going to say that I equals, and we'll concatenate the value of I. So very simple, and we'll just see the effects of what that particular loop does, and end. And as you can see, let's now look at it in one at a time. The begin end is basically the execution part of this very simple Pl-Sql block. We're saying we want to create a for loop. Everything between the for statement, loop, and then loop becomes the body of the loop. What are we doing in the body of the loop? We're doing a single statement called a put line of the package DBMS output. Now, every time through the loop, I takes on a value within that range. I becomes 1, then 2, then 3, then 4, and then 5. Every time we go through, we execute this statement, I equals, and the value of I. And as you can see, the output is I equals 1, I equals 2, I equals 3, 4, and 5. So you can clearly see the effects of how we would do it this way. Let's now look at doing the exact same thing, but this time we're going to use a while loop. So here we're going to say declare. I'm just going to declare I as a number here. And I'm going to say that I is initialized to 0. Now in the begin statement, I'm going to say while I is less than, and I'll put here less than or equal to 5. That's the condition. While that is met, I would like to loop. And what do I want to do in this loop? I want to do the exact same thing I did there. Exactly the same way. So the loop body is identical, except with a while loop, you have to do a bit more. You have to do something in there that makes the condition change. And what's the condition going to change? It's going to change when I eventually becomes, the condition of it being less than or equal to 6 is no longer honored. So I will add 1 to I. The most common error in dealing with while loops is forgetting to do some kind of operation that makes the condition eventually fail. And so I'll basically end the loop, and I'll end the block itself. We'll save the block, we'll execute it. And as you can see, the only difference here between our previous output is that we outputted 0 because we started at 0. Had I started at 1, it would be exactly the same output as we did before. But as you can see, a while loop is structurally very similar to a for loop, except that you do some kinds of conditions that they're used in different cases. In the for loop, you use it when you have a sequential type operation. A while loop is very general. It can be used for sequential and non-sequential type operations. But the while loop sometimes requires a little bit more work because you have to handle whatever it is that makes that condition eventually fail. Let's now add a few extra statements within the while or the for loop. Either one, it wouldn't matter. But we'll use the while loop for argument's sake, where we're going to basically try and exit prematurely based on some kind of condition. Let's look at how we would use that. I have listed at this point the current program that we had listed, which was the while loop version. And I'm going to add one extra statement to make this loop finish a bit prematurely. So what I'm going to do is I'm basically going to cut away these first few lines. So we're going to leave all of this the exact same way, including the increment. I'm going to make a copy of that and paste it in. And then I'm going to add to this some additional logic. I'm going to say if I is greater than 3, we're going to do something a little different. If this is met, we're going to say exit. And so when I exit out of this block, I'm going to exit a little bit sooner than we had thought. So I'll just do an end if here. I'll finish off the while loop and finish off the block. So there's our program. Let's look at it first in completed form. The only thing we did different, we're saying if I is greater than 3, exit the loop, otherwise carry on as usual. And then when we go ahead and run it, so what happened there is you see we got an error, and it tells you where it thinks it spotted the error. It says there's a problem over here. And then usually the line number may be a bit deceptive, but usually look around the area where the line number is, and you can clearly see I forgot a semicolon at the end of line 9. So all I've got to do is basically change line 9 and say change that if and make that if semicolon. Change the if to if followed by a semicolon. Change the if to if followed by a semicolon. And it won't let me do it that way, so I'll have to retype that line. So let me just list the program. I'll just do it just to be quick here, very quickly this way. And then and if followed by the last two statements here. All this is the same. So we do the end loop. So I added the semicolon at the end of that statement, which was the culprit. So as you can see, the difference between this output from the previous while output was that we were able to prematurely leave the loop by just testing an additional test within the body of the loop saying, by the way, if I is greater than 3, then exit. And so we were able to leave in that fashion. Now the last thing I want to cover is what happens when you do this using the exit when condition. So let's steal these lines here. I'll take these lines, and then I'm going to do an exit when to show you the difference between the two. Exit when, and here it's exactly the same thing when I is greater than 3. So in this case it's even easier to code, and everything else is the same. The end loop for the loop body and the end for the block. And we'll go ahead and run it. And as you can see, the results are identical, except in this case we used an exit when, which is much more compact than having to use the if then, and you're less likely to forget the semicolon doing it that way. Now there's a few little looping options that I haven't yet talked about. We just wanted to make sure that the basics were covered. Let's look at these additional features. Now in this particular case, we would like to create a loop, a for loop, but we are using the reverse option to say rather than have the loop go through 1, 2, 3, 4, 5, the reverse keyword indicates that we would like the counter to take on the values 5, 4, 3, 2, 1, and then basically do what was within the loop body. So whatever that loop end loop is. Now, a couple more different sequential control type statements which are usually not recommended. One is called the goto, and the goto has basically a bad reputation. And the reason for that is that a goto statement used excessively will make your program very hard to read. First of all, let's see what a goto does. A goto statement will let you branch from one place to another unconditionally. When you say go to, you say go to and you provide the name of the place where you'd like to go to. That name is called a label, and a label is basically an identifier enclosed within the double angle brackets. And it must precede one of the executable statements within a Pl-Sql block. In other words, you can say go to something, calculate some tax or whatever, and you'll go there unconditionally. Now, gotos have this reputation of making code very hard to read, and in fact it's true, and it's not recommended because you have many other better structured ways of doing the same thing. Nonetheless, let's just take a look at a little example of the reverse loop and the goto. First, we'll do the quick reverse loop one. And here we'll say for I in 1 to 5. Sorry, I forgot the keyword I wanted. For I in reverse 1 to 5. And then you indicate what you'd like to do. And what we want to do is simply dbms output dot put line. And here we will put the message again, I equals whatever I is. And that would be the end of the loop. So this is dead easy. The only thing we're doing different here is that we are saying loop through, but make the loop go through 5, 4, 3, 2, 1 rather than 1, 2, 3, 4, 5. And when you run it, your output comes up in a reverse order. So as you can see, if you need to go through something in a reverse order, it is ideal. Now let's do the same thing using a goto. And the goto, as I said, is not recommended, but nonetheless, you'll have at least seen it. Now, the first thing you've got to do is label what the part is. I'm going to call this thing, I'm going to call it my loop. And you see the angle brackets indicate the position within the code that you want to loop to. And now the statement I want to do is dbms output. And here I will simply put in a message here, I equals I as usual. And then, oops, I forgot to put line. So put line, followed by the string, and the concatenation. So we're just doing the same old thing. We're just going to display I, and then we're going to increment I. And then our test will be if I is greater than, say, 5, then we're going to say go to, and this is the statement, my loop. So if this is met, we're going to continue going back and forth up that loop. And that's the end if statement. So we're going to end the block now. And I'm going to have to just go back and fix a little thing. I'm going to declare the variable, which I forgot. And this is a common one. You can't use a variable unless you declare it. And I'm going to initialize it to 0. And then I'm just going to bring back those lines we did here. So I'll start off at the begin. And all our looping lines here. So all of this up here. And if you declare a variable, if you don't declare the variable, Pl-Sql will let you know anyway. So there's our complete program. Declare the variable I, begin, label the statement my loop, put an output statement out, increment I, do your test. If the test passes, then you would go to my loop. Now actually, I did the test in the wrong way. And you can see the confusion with gotos. I meant to say if I is less than 5, then continue looping. So I'm just going to change that test here to become less than. And so if I is less than 5, loop. So if this condition is met, we're going to go back. We're going to keep outputting. Eventually I will be greater than 5, and this can, or equal to 5. This test will fail. We will not go to my loop, and we will actually run the program. It will terminate at that point. So as you can see, we did the same thing we did, but it was much more painful using a goto. And if you have goto scattered everywhere, then the logic of the program becomes very unstructured. The term we use is it generates spaghetti code. It becomes hard to follow, hard to maintain, and generally not recommended. Let's now summarize everything that we've covered thus far in the Pl-Sql portion. Pl-Sql is basically a block-structured language made up of different parts. You have the heading, which we haven't spent any time on yet. We will see the heading when we talk specifically about procedures and functions. That is followed by the declaration section where you declared your variables, followed by the execution section where we spent the bulk of our time, and the last section, which we haven't seen yet, but we're going to be covering on immediately after this summary, is the exception section. Then we spent a bit of time on the scope and the visibility of variables. Where you declare a variable becomes very important. Once again, the rules are, A variable declared within one block will be seen within that block and will appear as global within subblocks. So if a subblock declares a variable by the same name as a parent block, it will hide it. In other words, it hides the visibility of that global variable. Declaring variables, we talked about all the different data types that you can use within Pl-Sql. The rules are very simple. You can use any valid SQL data type or any valid Pl-Sql data type. How do you assign a value to a variable? You use the : the assignment operator. What does anchoring mean? It means you declare a type of variable that is of the type of whatever the type of object it is referring to. For example, if you have a column within a table and that column is declared as number, by anchoring it as a type of that column, if the column changed type, the anchor follows it. So an anchor is better than explicitly declaring it as type. You don't need to know what type it is within the table to use an anchor. Then we spent a great deal of time on control structures. The various control structures we talked about included the conditional control flow, if then else, or if else if. And that meant that we could basically make a decision and execute this section or this section based on some kind of conditions. Then we looked at all of the various flavors of loops that we have. Your basic loop block, a for loop, a while loop, how we can prematurely end the loop using exit or an exit when condition. And finally, we covered the goto statement, which allowed us to basically unconditionally branch to any labeled portion of a program. And it was recommended that you not use the goto statement unless you have a real need to use it under some circumstances. So this concludes this section where we talked about the block structure of a Pl-Sql program, where we talked about all the different parts of the program, including the heading part, which we haven't seen much of, declaration, execution, and finally exception sections. Then we looked at the data types. Then we looked at the anchoring types. Then we looked at the various control flow statements you have, including conditional and looping control statements. In the next section, we're going to talk about exception handling. Now, of all the programs we've been looking at so far, they've been a little bit naive. Naive in the sense that we assumed everything was going to work perfectly. But in the real world, that's never the case. And this is where exception handling comes into play. Now, exception handling is what you can provide in the event that something goes wrong. And Pl-Sql gives you the facilities to detect and process predefined as well as any exceptions that you define, which we call user-defined error conditions. All of these together are called exceptions. Exceptions are things that you must handle when the flow of the program basically is disrupted by some kind of condition. A condition that could occur is something such as you went and did a select statement and the results returned were that the item you were looking for was basically not there. So what do you do in that case? You can't continue processing. You have to handle that exception. So when an error actually occurs within the execution block, an exception gets raised, and normal execution within that block stops. Transfer is then sent over to the exception handling portion of your program, and there you write special handlers that we call exception handlers. And they're like little mini blocks that you write to handle whatever it was that went wrong. The predefined exceptions are basically things already there for us that we can handle. They're predefined in the sense that they are already defined by someone. In this case, Oracle predefines them. And they get raised implicitly for us in the event something gets wrong. You don't have to do anything other than make sure you handle what would happen potentially. In other words, a very common one is that there was no data based on the query you might have made. You will get an exception for that type. It's a very common one. You'll see it documented in the table. We'll see it a moment from now. If your code doesn't handle the exception, basically it will terminate. And that would be not exactly what we want in an ideal case, because it's sort of ending prematurely, and it will look like something went really wrong as far as the users are concerned that use your Pl-Sql program. To make your program really rock solid, you should handle all possible exceptions. Now, in the event that you create your own exceptions, you can call a function called raiseApplicationError, part of the DBMS standard package, and I'll explain what those are in a few moments. It allows you to issue a user-defined error message from within your subprograms. Now the numbers you should use should be within the range minus 20,000 to minus 20,999. In other words, that's a range reserved for users. So here's what we do within the exception block. The syntax is very straightforward. The keyword exception indicates that this is part of the exception block. We have one or more when clauses. When this exception occurs, then do these statements. When this exception occurs, then do these statements. When anything else occurs, the keyword others indicates that, then do these statements. So we combine this exception block with our existing Pl-Sql program, and when we put it all together, here's an example of how we would use it. The first thing we have is a declaration section. It's very important to remember that you have to declare a variable indicating that it is an exception of the type that you are creating. So salary error is a user-defined exception, and we declare it as such. Then we have a variable, as usual, a number, current salary. Then we begin the program block. And what we're saying here is select salary into this variable where from the table employee, where the employee number is whatever the employee number in was supplied by. Now, it's very possible that there may be no employee given this particular number. What happens in that case? Well, we would be able to catch that exception. But let's suppose for the moment we're not worrying about that particular point. We're going to see how we handle that in a moment. Let's assume that our exception handles that a salary should never be greater than 10,000. We would say, if in the event this query successfully completed and the salary was greater than 10,000, then raise our exception. So we're basically saying, hey, something went wrong within our code, raise this exception. And then within our exception block, we're saying when this exception occurs, which we know we could raise, then we would put out a little message, salary exceeds 10,000. And so we get a little indicator that something went wrong. Then when any other exception occurs, then we do a null block in this case. We don't do anything, so it's simply a null statement. And then we end the Pl-Sql block. So that's how you put it all together. Now, here's a real procedure using the raise application error function. We create a procedure, and we're going to see how we do that a little bit later. But for the time being, the only difference from everything we've done so far is that this portion has a header. We're using the keyword create procedure, raise salary, given an employee, and given some increment, and then we declare a variable. So the header says this is the name of the procedure, these are its parameters, and here is the body. Everything else is something we've seen already. We're saying the current salary is a number, select the salary into the variable, everything we've seen so far. If the salary is null, something went wrong, we raise application error, we use a number, and remember the range we're allowed to use, and we say that there is no salary for that employee. Otherwise, everything is healthy, and then we do an update statement, update the employee table, set the salary to be the current salary plus whatever that increment is, wherever that employee equals that employee number in. And in the event that anything went wrong, you trapped it here and you raised it. So that's an example of a little procedure doing that. Let's now create a small Pl-Sql block so that we can see how raise exception works. Okay, now what I'm going to do here is I'm basically going to select some statements from, create a table here. Let's say select star from our temp table. And we have so much data in there, I'll simply truncate it. So truncate and temp. Oops, I forgot the keyword, table. Truncate, table, temp. So there's no more data in there. And just for argument's sake, I'm just going to put some data in there. So if I sort of select now, there should be nothing there. Okay, now if I go ahead and do an insert into temp, and I put the following values in. And let's suppose I put in -1, 1, and a string, ABC. And then we repeat our select statement. And even though this table is fictitious, it will make the point we need to see. Now, in the declare section, we're going to declare, and we're going to declare a thing called bad val, and this is an exception. So we have to remember to declare the exception. And then we're going to declare a second variable called C1 val. And this will be a simple number. And then what we're going to do is basically start creating a little piece of code. And this is very typical of what we did earlier. And I'm just going to select the C1, and I'll put it into C1 val from the table temp. And the condition will be where C2 equals 1. I just want to get that particular row out and store the C1 value into the variable. And let's assume for a moment that this was, again, we're fabricating this simple thing just to understand the way exceptions work. Now, once we've done this thing, we can do a simple test. We can say, if C1 val is less than 0, we can assume that this is not quite what we expected. We would say raise, and I would raise, in this case, the exception bad val. So that exception gets raised. Else, we would do whatever it is that was successful. So db ms output dot put line. And here I'll put in a little message, OK. So everything went well. And we'll end that particular block. So that would be normally the end of our program. At this point, however, we might want to raise some exceptions. So let me first handle the exception. And let's see what happens now. Now, if the exception is the one we just caught, which is bad val, we indicate that when this condition occurs, we're going to put out a little error message. And in this case, the error message is that we caught the exception. Caught exception. And that means we handled it successfully. And that will be the end of the block. And I'll show what happens if something else occurs in a moment. So there you have it. Very simple case. And let's just now look at all of the program together. So we declared an exception. Very important to declare it. We declare a variable to hold some values. We've seen all that before. Then the begin and end block. Select C1 from this table, putting the value into C1 val, our variable, where C2 equals 1. If there is a value that's less than 0, then we raise our exception. Otherwise, we display a little message. If this exception occurs, then we try to catch it by having one or more when blocks. When bad val, then do this. Otherwise, we don't enter there at all. So let's look at all the various things that can occur with this simple example. So when we run it, as you can see, we caught the exception because the flow of the program was when C1 got picked out, its value was in fact less than 0. We raised the bad val exception. We went over here and we displayed our thing. Now let's modify our table by basically saying update temp and set C1 equals 10, a positive number, and where C2 equals 1. So we're just going to update that row. And now we select that row to confirm our update. As you can see, it's now a positive value. So if I were then to go back up there and basically take my program back here as we had it, and just paste it back in and give it another try now, you see that our exception in this case was not fired because this statement got executed because C1 was not negative. And so the program handles any possible condition. Now, just before we lead into the next topic, let me show you one thing it does not handle. Let's suppose I made a small change to this program, or actually I'll just update the table. I'll say update the table temp, setting C2 equals 10, where C2 equals 1. So we just update the table. And so there is no value C2 equals 1. So once again, if you look at our program up here, we have the condition, try to select data based on the fact that C2 should equal 1. But that condition will not be met. So you'll see that there's still a big hole in our program. Let's run it. And what happened there? Well, what happened was this particular statement failed. It went to the exception block, but we did not catch the exception, no data found. That's part of what we call the built-in predefined exceptions, and that's the next topic. Now, our program is doing really well there. We've improved it immensely by handling some of the logic conditions that could arise as a normal flow. But we did not catch the things that are predefined. Let's see what we have in the way of predefined exceptions. Now, here are some of the predefined exceptions that we have. This table is in no way complete, and in fact, you'll see a complete listing of it in your notes, and of course, the online help you have within the product. Some of them won't make sense yet because we haven't talked about some of the features in here, but the ones that are obvious to us, I'll spend more time on. One of the errors that can occur is when you have something called a cursor, which is a variable we're going to see in the next tape, which is something that will allow us to sweep through a table. If you already have a cursor open and you try to open it a second time, you'll get that error. Another possible error is you're trying to do some kind of insert or something and you have put in a duplicate index when the index was supposed to have a unique value. You'll get that error there too. Trying to close a cursor that isn't open, again, we haven't talked about cursors, you'll get an invalid cursor. Trying to do an invalid conversion from a character to a number, you'll get an invalid number exception. Trying to log in as a user without the proper account and password information, you'll get a login denied exception. And the one we care about for our particular situation is no data found. We tried to do a select with a certain condition that just didn't happen. Well, the exception no data found will get triggered, and you're going to get this one. So this is a very, very common one. Or trying to do something when you're not logged on, you're going to get a not logged on exception. Some kind of internal program, you're going to get a program error exception. A row type mismatch, trying to assign some row into a variable of the wrong type, you get a row type mismatch. And this is probably because the anchoring row type was not used. And we're going to see why anchoring becomes even more important because you don't have to worry about this kind of situation from arising. You could get what we call a storage error exception where Pl-Sql runs out of memory. And finally, trying to wait for something and you timed out, you'll get a timeout on resource exception. So as you can see, there's a number of different exceptions, and we can improve our programs immensely by handling them and making sure that we also handle the condition when none of the above are caught, we still do some kind of error handling. Let's see how we can make our program that we just wrote a bit more robust. Now, at this point, let's take a look at how we would modify a program to handle not only the user-defined exceptions, but all the built-in ones. Let's take a look at the most common one, no data found exception. Now, we have something very similar to what we've seen earlier. We have a declaration of an account number. We do a select statement, and we're trying to get information on this account. Well, the possible things that could go wrong are that account doesn't exist. In that case, this exception will get fired. And notice no data found is not declared anywhere. It's basically pre-declared for you. You just simply handle the exception. And at that point, you put a little message, no data found, for the account number you were trying to retrieve, and there you have it. But another good thing to do is to put the when others clause in, which we did not do, and we left it out on purpose, so that you could see what happens when the program crashes when you don't handle exceptions. And in this case here, the when others allows you to handle any exceptions that you did not previously anticipate were going to occur. Now let's move over to SQL Plus and basically modify our little program we wrote a few moments ago and make it handle all of the predefined exceptions that we are interested in. Now, as you can see here, when we didn't handle the exception, we got basically a program crash, no data found, and it failed right away. And trying to do the select statement, there was basically nothing that met that condition. So the whole first part of your program is actually fine. Everything here is okay. The problem is we need to add to that, so we'll just make a copy of that, paste it in. And now I'll handle the other types of exceptions. So the way to work with predefined exceptions is you basically put the when clause in, you flip over to your notes, and you would look up on the table that we provide, and you say, well, what is the thing we have? And the exception is no data found. and any others that you're aware of that may occur. And then at this case here, I would put out a similar message. I would say then, and I do exactly what I did here, some kind of message. In this case, I might put here no data found, no data from the select clause. And then I can make sure that I catch everything, including even the ones I didn't expect, when others. And then you could put here a then and paste in just list it all again here. I have to continue typing. So basically I left out some stuff here. So everything we had here is okay. And then I'll put here another DBMS output statement. Dot, put line again. And I'll put here that this is an unknown exception. And there you have it. That will end our block. So we are now very robust. We're handling everything that could happen. Let's just list it completely. Everything is the same as we saw earlier, except not only are we handling our own exception, but we're handling the built-in one, no data found, and any others that may arise that we did not anticipate. So let's give it a try here, and I'll basically run it. And it said no data from select. And if you recall, run temp, nothing met the condition that C2 was there. And so we handled it nicely. So C2, if you look at the select statement, we're trying to get information where C2 is 1. That resulted in no data. We went to the exception area. It was not a bad value exception, but it was a no data found exception, and then we executed this statement here. However, if it was none of the above, we would have still caught it because we handled all the exceptions with the when others clause. So that's the power of exception handling. It makes your programs not crash under any circumstances. So what we just saw in this section was basically how we can make our Pl-Sql programs more bulletproof by introducing exception handling. This allows you to trap user-defined as well as any predefined exceptions that are there. Now, what we covered off in this tape, we started off with an introduction to some of the new features of Oracle 8 as it pertains to Pl-Sql. Then we moved into what is the basic structure of a Pl-Sql program. We know it's made up of 4 sections: header, a declaration section, an execution, as well as an exception handling section. Then we looked at some of the data types were allowed, any Pl-Sql data type or any SQL data type. And then we moved on from there. We looked at some of the control flow logic statements we have, such as if-then-else statements and any kind of looping constructs, for loops, while loops, and so forth. And we wrapped up this section by looking at exception handling. Now, what we're going to cover off in the next tape are all of the more advanced issues, including cursors, declaring functions, procedures, and basically a little bit more in-depth of some of the more advanced features of Pl-Sql.
We hope you've enjoyed this training session and, more importantly, increased your knowledge and productivity. Keystone Learning Systems offers hundreds of courses, including MS Office, Novell Perfect Office, NetWare, Lotus Smart Suite, Lotus Notes, Power Builder, Corel Draw, PageMaker, and many, many more. Each is designed to accelerate your learning curve and increase your productivity. Each makes a nice addition to your computer training library. Call us today if you have any additional questions or would like to place an order. Our phone number in the United States and Canada is 1-800-748-4838. And if you're calling from somewhere else in the world, please dial 801-375-8680. Thank you.